Look up from Seattle or Tacoma on a clear day, and you'll see it. A majestic presence that dominates the horizon, a constant reminder of nature's grandeur. A colossal peak, draped in white, piercing the sky. Its icy crown glistens in the sunlight, a beacon visible for miles. This is Mount Rainier, the monarch of the Cascade Range, a sentinel standing guard over the Pacific Northwest, standing over 14,400 feet tall, an imposing figure that commands respect and awe. To millions, it's a serene, postcard-perfect backdrop, a symbol of tranquility and natural beauty. But beneath that beauty lies immense power, a force of nature waiting to be unleashed. Mount Rainier is not just a mountain, it's a complex geological entity. It's an active stratovolcano, a living system with deep, fiery roots, constantly shifting and evolving beneath the surface. Its glaciers feed rivers, providing life-giving water to the surrounding ecosystems and communities. Its eruptions have shaped the land, carving valleys and creating the very landscape we see today. And its story is one of both creation and destruction, a testament to the raw power of the Earth. Understanding this cycle isn't just science, it's survival, a crucial step in protecting the communities that live in its shadow. Volcanoes are dramatic agents of change, capable of reshaping entire landscapes in a matter of days. Reminders that the ground beneath us is alive, constantly moving and shifting with unseen forces. Rainier's size, composition, and proximity to cities make it both magnificent and dangerous, a constant balancing act between beauty and risk. We're drawn to its beauty, captivated by its majestic presence and stunning vistas. But we must respect the forces within, acknowledging the potential for destruction that lies dormant beneath the surface. Scientists use geology, the study of the Earth's structure and history, seismology, the science of earthquakes and seismic waves, and chemistry to listen to the mountain's whispers, analyzing gases and rocks to understand its inner workings. Living in the shadow of a giant means learning its language, understanding its signs, and respecting its power, and preparing for the day it stirs, ensuring the safety and well-being of the communities that call this region home. The story of Mount Rainier is our story, a shared narrative of coexistence and respect, a relationship with the powerful forces of our planet, a constant reminder of the Earth's dynamic and ever-changing nature. Why so much focus on Mount Rainier? What makes this particular peak so deserving of our attention, our resources, and our concern? Because it's a Decade Volcano, a title reserved for the world's most dangerous volcanoes, a select group recognized for their potential to cause widespread devastation. Chosen in the 1990s, only 16 volcanoes worldwide earned this designation, a testament to the unique confluence of factors that make a volcano truly hazardous. Including Rainier, due to its explosive history, a past punctuated by powerful eruptions that have shaped the surrounding landscape, and the hundreds of thousands living nearby, communities nestled in the shadow of a giant, unaware of the potential danger lurking beneath their feet. As a Decade volcano, Rainier is under constant scientific scrutiny, a watchful eye kept on its every move, every rumble, every subtle change, a natural laboratory for volcanic hazards, a place where scientists can study the inner workings of a volcano and learn how to predict its behavior. Scientists monitor every tremor, every puff of steam, searching for clues that might precede disaster, piecing together the puzzle of Rainier's volatile nature. The main threat isn't a Hollywood-style eruption, but the mountain's immense cloak of ice and snow, a seemingly benign feature that holds the key to Rainier's most dangerous potential. Rainier holds more glacial ice than all other Cascade volcanoes combined, a vast reservoir of frozen water poised to unleash its fury. Over a cubic mile perched on unstable slopes, this mix of heat and ice is a recipe for disaster, setting Rainier apart. If the volcano awakens, its heat could unleash torrents of water and mud, creating devastating lahars that could bury entire communities. The Decade Volcano designation is a global recognition of a local threat, a reminder that the forces of nature can transcend borders and impact us all. A call to action. We cannot afford complacency, we must study, monitor, and prepare. Science is our best defense against the risks posed by this magnificent, dangerous peak. Living near Rainier means respecting its power and being ready for whatever comes. It requires vigilance, education, and a commitment to community safety. To truly understand the potential danger that Rainier poses, we need to delve into its very composition. Let's take a closer look at its makeup. Unlike the solid, unyielding granite peaks that stand firm against the elements, Rainier is classified as a stratovolcano, a structure meticulously built layer by layer over millennia. These layers are composed of lava flows, unconsolidated loose rock, and fine volcanic ash deposits. The result is a massive, inherently unstable pile of rubble, a collection of geological materials. These layers are held together, but only imperfectly, by time and pressure. Adding to this precarious situation, 25 glaciers sit atop this fragile structure, a heavy burden. These glaciers are constantly grinding and eroding the mountain, further weakening its internal structure. Deep below the surface, a magma chamber heats the mountain from within, adding another layer of complexity. This magma sometimes rises, intruding into the rock and altering its composition. This process transforms the rock into a weak, clay-like material, further compromising the mountain's integrity. This dangerous combination, the steep, unstable slopes, the presence of weak rock, and the immense weight of glacial ice, creates a precarious balance, a delicate equilibrium that could be easily disrupted. A full-scale catastrophe doesn't necessarily require a major volcanic eruption to unfold. A relatively small explosion, a moderate earthquake, or even the relentless force of gravity alone could be enough to trigger a catastrophic collapse. Rainier could potentially fall apart with very little warning, unleashing its destructive power. This makes it a uniquely hazardous volcano, demanding our respect and vigilance. Unlike Hawaii's Kilauea, which typically erupts in a relatively gentle manner, Rainier's unstable structure and the presence of massive amounts of ice combine to make it a far more dangerous and unpredictable geological entity. Its potential for widespread destruction stems from both the volatile materials contained within and the very composition of the mountain itself. It's truly a creature of ice and fire, a testament to the powerful forces of nature, undeniably beautiful, yet inherently fragile. Therefore, the real threat we face is not solely from a potential eruption, but from the mountain's own inherent structural instability and the potential for catastrophic collapse. A comprehensive understanding of these factors is absolutely key to accurately grasping and assessing the true extent of Rainier's risk. It's a giant in stature, but a vulnerable one in its geological makeup. If you remember one word about Rainier's risk, let it be lahar. A lahar is a volcanic mudflow, a fast-moving river of mud, rock, and debris, more dangerous than lava. Lahars can travel up to 50 miles per hour, scouring and burying everything in their path. This is Rainier's primary hazard. Even a small eruption can melt vast amounts of ice, mixing with loose rock to create a lahar. These flows surge down ravines and into river valleys, threatening towns like Orting, Puyallup, and Sumner. The valleys below Rainier are ancient lahar pathways, now home to tens of thousands. A large lahar could reach Puget Sound, burying communities under mud and debris. Catastrophe doesn't require a full eruption. A landslide or collapse could trigger a massive lahar with little warning. The greatest threat from Rainier isn't fire, but water and mud, a force that can erase towns in hours. Understanding lahars is crucial for everyone living in Rainier's shadow. To see what a Rainier lahar could do, look to history. In 1985, Colombia's Nevado del Ruiz, a volcano much like Rainier, erupted, melting ice and triggering lahars. The mudflows swept through Armero, killing over 23,000 people in minutes. The eruption was minor, the lahar was catastrophic. Closer to home, Mount St. Helens's 1980 eruption unleashed lahars that traveled 60 miles, destroying bridges and homes. These disasters show that lahars can devastate areas far from the volcano itself. River valleys become channels for destruction, carrying mudflows into populated regions. Scientists study these events to model Rainier's risks and create hazard maps. The lessons are clear. The danger zone extends far beyond the mountain's slopes. Past disasters are warnings we cannot ignore. Preparedness and understanding are our best defenses. The mud of other mountains teaches us how to protect our own communities. We must heed these lessons to safeguard lives in Rainier's valleys. Magma isn't the only threat. Hydrothermal alteration quietly weakens Rainier from within. Water seeps into the mountain, heats up, and circulates, turning hard rock into soft clay over thousands of years. This process creates zones of weakness visible as colorful scars on the mountain's face. These altered areas are most likely to collapse even without an eruption. The Osceola mudflow, 5,600 years ago, was triggered by such a collapse, burying over 200 square miles, including present-day Enumclaw. Hydrothermal alteration is a silent, ongoing threat, making the volcano dangerously unstable. An earthquake alone could trigger a massive landslide and lahar. Scientists monitor not just seismic activity but also the chemistry of gases and water, searching for signs of increased alteration. The mountain's slow internal decay is as dangerous as its eruptions. Understanding this process is vital for predicting future hazards. Rainier's greatest risks may come from within, not just from fire but from slow, silent change. Vigilance is key to staying ahead of this hidden danger. How do we keep watch over such a threat? With science and technology. The Cascades Volcano Observatory, part of the U.S. Geological Survey, constantly monitors Rainier. Seismometers detect tiny earthquakes revealing magma movement or rock stress. GPS stations track subtle changes in the mountain shape, signaling possible eruptions. Gas sensors monitor volcanic vents for changes that might indicate rising magma. The Lahar detection system uses buried microphones to sense the rumble of approaching mudflows. When triggered, it sends instant alerts to emergency agencies. This network can't prevent disaster, but it can provide precious minutes of warning. Every instrument is a lifeline, helping us listen to the mountain's signals. Science is our best tool for early warning and safety. Science alone isn't enough. Community preparedness is essential. In Rainier's shadow, towns practice lahar drills and post-evacuation route signs pointing to high ground. Schools teach children to recognize warning sirens and calmly evacuate. Emergency managers coordinate warning systems, sirens, broadcasts, and phone alerts to move thousands quickly. Monthly siren tests remind residents of the ever-present risk. Plans are constantly refined, but responsibility also lies with individuals. Every family needs an emergency plan, a go bag, and knowledge of evacuation routes. Hope isn't a strategy practice, and preparation save lives. The work done here is a global model for hazard mitigation. It shows the power of taking scientific threats seriously and building resilient communities. Preparedness turns fear into action. By working together, we can face the unthinkable. Readiness is our best defense. Mount Rainier is more than a mountain. It's a neighbor, beautiful and dangerous. Its story reminds us we're part of a dynamic, ever-changing planet. Ignoring this reality isn't an option. Our survival depends on understanding and respecting nature's power. Constant monitoring is an act of humility and wisdom. Volcanology deepens our relationship with Earth, turning data into dialogue with the mountain. There's no need for fear, but vigilance is essential. Complacency is the real enemy. Rainier's quiet can lull us into false security. The evidence is clear. It will erupt again. The question is when. Our technology, planning, and awareness are our tools for facing the unknown. When you look at Rainier, see both its beauty and its power. It teaches us about geology, risk, and responsibility. By keeping watch, we honor our place in the cosmos and protect our communities. The mountain is a silent sentinel, reminding us to stay vigilant, always.